All right, we're covering 7-2, which is the inverses of relations and functions. So we're going to graph and recognize inverses of relations and functions, and then find the actual equations for inverses. So to graph the inverse relation, you can reflect each point across the line y equals x. So y equals x is a line, and it's a diagonal across the xy axis where the value of x and value of y are the same. However, the way that we're normally going to graph is we're going to switch the x and the y values. So the reflection over that line is the same as just switching your x and y values in the ordered pair. And that's how we're going to be doing it. So it says graph the relation, connect the points, and then graph the inverse. So here is our relation, here are x values, here are y values. So we're going to graph those ordered pairs, and I'm going to show you that in just a second. The inverse, then, we're just going to be switching. So these are going to go up to your x, become x values. These are going to go down to become your y values. So here's the table, and you can see x and y values have been reversed. So if we plot them, our blue is the original. So here's our 0, 2, 1, 5, etc. This is what that one looks like. When we reverse it, we start with 2, 0, 5, 1, and our red line then would be our inverse. And you can see these are the points for y equals x, and this is a reflection across that line. All right, it also says identify the domain and range. So here, if we look at the domain and range of this function, our domain goes from 0 and stops at 8. So x is between 0 and 8. And our range, we start at 2 and our highest value is 9. So our range is going to be between 2 and 9. So this is our original function domain and range. Okay, the range and domain and range for the inverse is going to be just the opposite. So you can see here our domain starts at 2 and goes to 9, so it's between 2 and 9. Our range starts at 0 and goes up to 8. So again, what happened? We switched, which is what you would expect when you swap your x and y values. Okay, this is one for you to do. Graph the relation, connect the points, graph the inverse, and identify the domain and range of the original and the inverse function. Okay, when a relation is also a function, so remember, not all relations are functions. We know it's a function if it passes, when you graph it, it passes vertical line test. So if it is a function, you can write the inverse function, and the notation for inverse function is, and that the font there doesn't look that good. It's actually f with a little subscript -1 of x. So it doesn't indicate the reciprocal like it does we have for exponents. X to the -1 power is 1 over x. This actually means the inverse, not the reciprocal. So functions that undo each other's operations are inverse functions. So here's the example. If we have some function, you input a 3, it adds 6, so this is your actual function, x plus 6, and your output is 9. What's the inverse look like? You take 9, and we're going to end up with 3. How do we do that? We have to subtract 6. So basically what we did was undo that operation, which is the operation that we performed on x to change it into y. So we're going to look at a couple examples of undoing the operations to write the inverse function. And then we're going to look at what I think is the better way. It's really the only way I've learned before this curriculum to write inverses. But this is kind of a simple way to conceptually understand what's going on. So the function is f of x equals x times negative, or x minus 1/2. So we took x, we subtracted 1/2. How do we undo that? Well, we're going to add the 1/2 back. So how do you undo a subtraction of 1/2? You're going to add 1/2. And it's pretty much, for this one, it's just that simple. That's going to be your inverse function. You can check it. How do you check it? Well, we want to input x equal 1 in here. What do we get when x equals 1? It's going to be 1 minus 1/2, which is 1/2. Now we're going to plug 1/2 in here and make sure we get 1 back with the original input. So if we plug 1/2 in here, 1/2 plus 1/2 equals 1. So you can see we went from 1 here, x equals 1 here, and a y equals 1/2. And here we had an x equals 1/2, and we got a y equals 1. So our values, x and y values, were switched. So it is the correct inverse function. So again, it always helps to check, because sometimes we make mistakes, and if you check, it usually catches those. All right, and second example. So here we have, it's a more complex example, f of x equals 3 times x minus 7. So what do we do to x? Well, the first thing we do is this is a little bit confusing. The way I look at it is, if this were my y, so what do I do to x to get to y? Well, I subtract 7 and multiply by 3. So how am I going to undo this? Well, I'm going to divide by 3, which is the same as multiplying by 1/3, and then I'm going to add 7. So basically it's going to be 1/3 x plus 7. And it's a little confusing because the order of operations is also kind of reversed. Here the order of operations would be adding or subtracting the 7 and multiplying by 3. Here we're going to undo it by reversing that order of operations. We're going to undo this multiplication first, and then add the 7. So this is our inverse function. All right, so this is a simple one. You should try and undo this and write the inverse function of f of x equals x divided by 3. Now, as I said, this is the way that I actually have learned to write inverse functions. You inverse function by writing the original function with x and y switched. So we're going to switch the x and y, and then we're going to solve for y. And I think this is easier because sometimes when you get multiple operations, it's hard to figure out the order that you undo things in. All right, so graph f of x equals -1/2 x minus 5, then write the inverse and graph that. All right, so we'll get to the graphing in a minute. Obviously, it's a linear function. This is our y-intercept. This is our slope. So we should be able to graph that function. And if you forget that, you can always use a table of values to graph it. For a linear function, you only need 2 points. To write the inverse, now, this was the original function. So f of x is the same as y, so it's y equals -1/2 x minus 5. We're going to switch those. So we're going to put the x here. Whoops. We're going to put the x here. Can't seem to get this. Here we go. Put the x here and put the y here, and then solve for y. So that's what we've done here. So again, first thing you're going to do, you're going to add 5 to both sides. And then we're going to get rid of this by multiplying by the opposite reciprocal. So if we multiply by -2/1, and we have to multiply the whole thing by -2/1. These cancel out. We distribute this, and you're going to get y is equal to -2x minus 10. So this is our reciprocal function. And actually, they've left it like this for some reason. I would probably leave it in slope-intercept form here. And now we're going to graph. So the first function, which they graph as a blue, our y-intercept is -5, which is right here. And we have a slope of -1/2. So we're going to go down 1/2. And we have our 2 points. Now we can draw that line. For this one, we have a y-intercept of -10, which let's see, this is 3, 6, 8. So 10 is down here. Unfortunately, they didn't make the graph big enough. Whoops, I want to actually make this a red one. So you have a negative 10 down here, and then you have a negative slope as well. So you can tell the slope here. You would go up to 8 and over 1, and that's going to give you your linear graph. And here's the line y equals x, this dotted line, which you can, if you look real hard, you can see they're reflections of each other, but it's much harder to see it. So it's a much better way to graph an inverse is to find the equation of the inverse and then graph. All right, so I think the next one is for you to do. Make sure you can figure out how to write the inverse and how to graph both. And then just a simple application. This is showing you how, I mean, we do use inverses a lot whenever you need to work backwards to find an answer to a question. Is basically you're using an inverse type of function. You might not realize it, and I think maybe the way they show you how to do this is not the way that this procedure that they go through the steps might not be exactly what you would have done. It's not the way I would have done it, but they're using it to illustrate how we do use inverses out there in the real world. So it says Juan buys a CD online for 20% off the list price. He has to pay $2.50 for shipping. The total charge is $13.70. What's the list price of a CD? So this is a problem you could probably imagine coming up at some point in time. This is actually an inverse problem. You don't know what the original list price was, so you're going to work backwards to figure out what it is. So they set it up. We know that the cost of the CD, which they define as L, the list price, was 80% or 20% off, which is 80% of the original price, plus the $2.50 for shipping. And they're going to get L by itself because that's what we want to find. Before they actually, we probably would intuitively put $13.70, that's how much we paid here. They wait and do that at the end because they're illustrating how in reality we are using an inverse to solve this type of problem. So anyway, they're solving for L, which is the inverse of this function. Subtract 250, then we're going to divide by 0.80, and our list price is going to be the cost minus 250 divided by 8.8. And then now they plug the 1370 in for cost, and we see this is what our list price would be, which is $14. So inverses are useful, even though we don't really think of them as inverses. We don't know that we're actually using them, but we often do work backwards to figure out what the original value of something is. All right, so that is the last slide. This is your homework. If you have any questions, please bring them to class.